So welcome to the third module entitled Protocols and Models. In this module, we are to tackle rules in computer network. We'll set some analogy as well. Protocols, protocol suite, um, standards. We'll cover difference between standard to a protocol and list enumerate some of the standard organizations. Reference model, a very important topic. We'll discuss, have an overview of the OSI and TCP/IP model, a detailed a discussion about data encapsulation. So, um, rules, okay? Just like when two person communicate, as we observe, there are rules to be followed, right? Say example, you say hi, you should know who the name you are talking to, right? And then once you're through with the conversation, you say goodbye or take care. Same thing in computer networks. There are rules to be followed when sending a message or a data, say from one PC to another PC. Okay. Um, Okay, so that's the title of this part of the module. Okay, so some um, um, before we proceed to the exact rules, take note that in a communication there are three elements. So you have the source, you have the destination, and of course there should be a media, a channel that connects the source sender to the destination, the receiver. Okay. I have an analogy here again. Say, when two persons talk to each other, of course, there should be a message, and then there should be a destination. Okay. One good analogy also, just like in parts of our body, there is a part of our body that acts as a transmitter, the one that relays the message, and that is our mouth, right? And on the other end, on the other side, like the other party, the one that there's also a part in the body that receives the information, and that is and that is the ear of this guy, right? So there's the mouth, the transmitter, the ear, the receiver, and then there's the medium. Like in the case of these two persons talking, the air. So in computer network, same thing. There is a transmitter circuit on the side in the side of the sender. Of course, there's a message to be sent going to the receiver. In the destination, there is a receiver circuit. Okay, and of course, you have the medium, the cable that is used to connect the source to the destination. Okay, and then aside from these basic components, and again, talking to each other, two persons, there are protocols being observed, same as in computer network. There are rules that are being followed, and you need to be familiar with these rules or protocols. Uh, Example of rules is you need, like in computer network, it is very important to identify the sender and the receiver. This is why we have addressing, like IP address. We mentioned that in module 2, right? There are also common languages and grammar. You are done with web, right? Like browsers has a language, right? What's the language? Very good, that's correct. HTML. I heard you answer that. Okay? Oh, so HTML, hypertext markup language, that's the language of the browsers. So there are application software that has languages. Database is SQL. Same as with us humans, right? We have languages and grammar. There are persons that talks too fast. There are persons that talk too slow, right? Same thing in computer network. There's also speed and timing of delivery in the message. And then there's this confirmation or acknowledgement, because just like with us, no, sometimes when we relay message, there are instances, there are errors encountered, right? And we usually say, uh, if we feel that the message has errors or mistakes or it is not clear, we usually ask the sender to repeat it, right? Same thing in computer network, uh, where there is a mechanism that the receiver can detect these errors, and once an error is detected, what will happen is a correction mechanism will be applied, and that is to repeat, resend. We will discuss that further in the transport layer. Some of the network protocol requirements have something to do with encoding, formatting, size, timing, delivery options. Let's deal with this one by one. So like with encoding, usually most part of this occurs in the cable, LAN card to cable. Okay. What we mean by encoding is this is the process of converting the information into acceptable form of transmission. Take note that our message is transmitted to our wire, to our cable. Okay. And the nature of the signal in our cable is different to our computer. So there is a component that encodes this or converts this. Usually it occurs on the LAN card. Okay, the specific component in our computer where our cable is connected is the LAN card. So there is a component there that encodes the uh, the message so that is needed in a way for this message or data to be transmitted to our cable. On the other end, on the receiver side, it will be decoded. The signal from the cable will be revert back to the acceptable information to the information acceptable by our computer. So it can be read. There's what we call as encapsulation. The data being transmitted. Example like this one, there's a letter. Dear Jane, just like with an envelope, no analogy. Just like with an envelope. So you have a letter in an envelope. Just like this one, our data, like this one, Dear Jane, I just returned from my trip. It is being placed in an envelope. And then in the envelope, there are added information, right? Same thing in computer network. That our data, okay, it's not included in this picture, but there's a data here, somewhere there at the bottom. There are added informations, like this one. Oh, these are added informations in the data. Okay, the data is being placed in an envelope in computer network, and then there are added informations like IP address, um, versions, traffic class, flow label, so on and so forth. Okay, as we go along, we will um, have a detailed discussion on this added information. Just like this, this one problem is there's like too many informations, no? So this is what I told you during the overview. Okay, that one challenge in Cisco 1 is that there's lots of memorization in terms. But for now, for chapter 3, no need to memorize this yet. This part here, ignore this first. Ano, you will deal with this when we are on the IP addressing part. And then message size. Okay? Um, when you go to post analogy first, when you go to a post office, there is only an acceptable weight. If example, if the acceptable weight of your envelope, okay? Example, if it's too heavy, there's an instance that they will not accept it, right? Okay? Same thing in computer network. Okay? In computer network, if it's too heavy, if it's too many, it may be dropped like this one. Okay? We will discuss that when we are in the data link layer. That there is this what we call as an acceptable message size or frame. Usually that's the term, right term actually, frame. So, there. Okay? I think I'm okay with that. So in message timing, we have flow control. In flow control, this measures the rate of data transmission. If you notice, for example, we usually measure in terms of bandwidth. So for example, I send data now in my computer and say the data in my computer going to Google Drive. So at this point in time, it's very fast. But well, because when my computer see that there's too much bandwidth, so it will send more data. But let's say after 5 minutes, it sees that there's too much traffic. So it will only send a few. So that's what we mean by flow control. Okay, managing the rate of data transmission. Response timeout. Example, my computer, say computer A, it pings computer B. Okay, so it pings computer B. It says, "Hey, computer B, are you there?" Okay, it shouts to the network, "Hey, computer B, are you there?" Okay, um, computer A will wait for a reply coming from computer B. Okay, and then it has this expected time that that's the time that B should reply. If B, for example, did not reply after 10 milliseconds, then that is the time that computer A will say request timeout or response timeout. Okay, and then access method is the manner of our technology to send data. We will discuss this when we are in the Ethernet. Okay, like what is being mentioned here, it's all about Ethernet. Like Ethernet, its access method is it uses broadcast. Every time it sends data, it sends it to all. Okay, and then with that, there is this collision that, of course, we will discuss that further in the Ethernet chapter discussion. And then we have three message delivery options or transmission. There's that unicast, like a switch. Okay, a switch can send a data specific to the destination. Example, I have this source here. It sends. I'll try this. I have this source here. It sends data to this PC here. So it has that ability to send it specific to the destination. Okay, a switch. This is good. Okay, this is good. It lessens congestion. Okay, if a device can send it unicast specific to the destination. You know what? There are some requests that sends it to all, like ping. I mentioned a while ago about ping. Example, source will ping this. So A doesn't know where this is located. The switch do not know where this PC is specifically located. So what the switch will do is to send it to all. If it is to all, that is broadcast. Okay? If it is to a group, example, this computer here and this one, they are in one group. So when this source is also on the same group, so when this source will send a data to this PC, it will send it to this group for whatever purpose. There are applications that uses multicast. Okay, but take note for now. Again, very important that again unicast specific to the destination, broadcast is to all, multicast is to a specific group. Protocols. Again, protocols are rules. Rules or protocols, it may be implemented to the software or on the hardware or both. Okay. Just like us, there are rules to be followed. Like just like right now, right? We need like you teenagers, you need to stay at home. So those are rules. Okay. Rules or protocols ensures interoperability, right? Like you, if you do not observe rules, then you will not be interoperable. Why? Because if you go out, you will be put into jail. There's an yeah, not like nowadays, right? It may happen. So if you are if you are in the jail, then you are not you cannot function, right? So and that's the sense of the of putting a person into a jail. So same thing here, ano? There are protocols in our application software that may have something to do with communications or security. We have protocols inside the router, and usually, one important protocols that a router has is routing. Okay, uh, and there's another protocol that has something to do with service discovery. Routing, routing protocols are like map. Routers has this ways inside, just like a ways. No, there's a map. Okay, so that's the use of the routing. You know what? In security example, diba, HTTP, the protocol of web browsers. But now there's HTTPS. And you know what? Trivia, because I'm also teaching information security. They are into a direction where they change all the application layer protocols. We'll discuss some of it later into a much secured one. They want to standardize the secured equivalent of those application layer protocol. Okay, because of the many threats we are encountering uh, especially in the internet infrastructure. There. Protocols may have something to do with addressing, like IP is internet protocol, right? Reliability, okay? Like guaranteed delivery, this is the agenda of TCP. TCP is also a protocol. There's also a flow control, sequencing in TCP. There's also a protocol for uh, process-to-process communication about application interface and error detection. Okay. Protocols interact with each other. Okay. So I have here a example, a topology. Say this laptop will connect to the internet going to this server. So in a way for this data to be delivered going to the server, protocols work with each other. So there's a protocol for Ethernet as it will fall on the like on the LAN card part. This is on the computer, and then okay, and then going to the IP address. Example ha, going here on the server. So in the Ethernet, it goes into the LAN port of this server. Say example, this refers here. Okay, so it goes on the first on the Ethernet protocol, and then after that, IP addressing is to be read, and then after IP is okay, then it will be passed on the TCP. Okay, TCP will take charge and does its work, and then pass on to the HTTP to the browser. Okay, we will discuss this further as we go along in the other chapters. So that ends chapter 1, and keep safe. Together we learn as one. Thank you.